Hello everyone. Today I'm presenting demonstration of VegaPlus, optimizing declarative visualization languages. Developing interactive visualization of large datasets requires significant efforts. The developer needs to test the different design choices and implement the underlying architecture to support interactivity at large scale. Visualization specification languages such as D3 and Vega make the process simpler and work well on the client side with small data, but they lack built-in support to coordinate between client and server-side data management and processing. Many existing systems try to address the scalability issue for specific dataset and interface scenarios, but they fail to support the level of expressiveness that D3 and Vega provide for innovative designs. We propose an alternative solution that increases scalability while also aiming to preserve the flexibility of the underlying language. We present a series of visualization and interaction-aware optimizations that can be integrated directly with existing visualization specification languages. Our approach automatically determines which computations to keep on the client and which to upload to a separate database systems, minimizing unnecessary network data transfer. Furthermore, our optimizer leverages knowledge of the compiled language structure to adapt and deploy database optimizations for interactive exploration context. In this way, we can use the computational benefits of DBMS while making it significantly easier for users to connect visualization tools with a data processor that they already available to them. We demonstrate our approach by implementing it for Vega. Vega is a web-based visualization tool. Its entire process, including loading and processing data, all happen in the browser. So the amount of data can be visualized is limited by the browser's memory, and all the computational load, such as performing data aggregation, is placed on the browser application running on the client machine. So the idea of this project is to automatically offload resource-intensive operations to a separate DBMS. First, we need to enable server-side supports. One powerful feature of Vega is that it includes a variety of data manipulation functions called transforms to cover data pre-processing tasks that are useful in constructing data visualizations. These features make it possible for the visualizations to accept raw data as input and then perform its own data manipulation, and removes the need to create intermediate data files. We replace its pipelines of Vega transforms with a custom transform type, and then register a JavaScript handler for this custom transform type. Then the database system can evaluate the translated query and send the result back to the browser. For large datasets that cannot be fully loaded or fast processed in the browser, raw data and the computations can be offloaded to a backend DBMS. So our second step is to partition the operations across client and server by selecting the optimal visualization plan that minimizes the latency. We optimized the part of the plan that is assigned to the server by node merging and SQL statement rewriting. Finally, since interactions impose an even stricter latency requirement for visualizations, we construct a prediction model with user modeling techniques for potential user actions to prefetch and cache requested data during the idle times. And we also repartition based on the predictions. Now let's move to our demo interface. we have implemented a live editor to showcase VegaPlus. But for the convenience purpose, we include a series of examples. Now let's demonstrate a simple histogram using the US airline flight dataset with 3 million rows. Even if it looks like a really simple histogram, it includes a series of transformations. The extend transform calculate the minimum and maximum values of a column, and then it's followed by a bin transform that assign a bin number to each of the data item. And then the aggregate transform count the number of entities inside each bins. So now the user can interact with both the VegaPlus and the Vega version. So now the user can get a sense of their performance and compare them. We also provide some additional information for users to inspect. For example, the data viewer shows the intermediate data result, and the data flow viewer shows how we partition the data flow nodes. For example, the highlighted nodes are our rewritten SQL queries, and they are placed on the server. When the user hover on the node, they can see the actual rewritten SQL queries. And our signal viewer record the user interactions. We also provide a performance view to show the user a performance chart for the comparison. Thank you for watching our demonstration. For more information, you can refer to our paper.